And I can see on screen that my screen is visible. Perfect. So today, what we're going to talk about is, the scope of the learning session today is applied ZK for builders, and I'll give a little bit more context as we go along. Before I dive into the topic that I'm going to discuss today, do a little bit of intro time. My name is Raza. I'm head of DevRel at Scroll. Scroll, if you're not familiar with, is a layer 2 ZK rollup. We're here to scale Ethereum through utilizing ZK technology, in simple terms, we've seen that Ethereum has proven product market fit, and believe are very much aligned with the ethos and the culture. So what we did is stuck close to the technology of Ethereum, and we're basically another network on top of Ethereum. We won't be diving into rollups today. I'll be talking about the state of developer experience in applied ZK. So just some context, a lot of the work that I do is I help bridge from where theoretical knowledge ends and is translated into what developers can use to build. And so ZK has gone, zero knowledge has gone quite a hype. It's taken off in terms of privacy and scaling. And today, what I want to provide you is the insight that I have with enterprises and early stage projects when they look at zero knowledge to utilize it for consumer facing retailing, but also when it comes to protocol level engineering. It's a lightweight talk, just as an FYI. I know there are a lot of smart folks in the audience, and happy to make sure that we come back and cater for a more theoretical talk. So I want to tell a short story about what it used to take to get started in ZK. One of the things that I do is I'm responsible for hackathons within Scroll, but I also visit a lot of hackathons to meet with developers. And so what it used to take to get started was actually a lot. This is me together with my colleague Ahmed, one of my team members, and we wanted to build a simple ZK voting app. And so we thought, we got this. What we're going to do is a very simple flow. A user logs in, upon logging in, we'll generate a proof based on the wallet address using, the ECDSA verification. We will verify this proof upon this user submitting their vote, yes or no, and then and the verification would happen on chain. Easy peasy, right? Not really. There's a lot more that comes into it, and so if you ever have participated in a hackathon, you will notice this stage. It's basically a meltdown where nothing is working. You're looking at your code, you're tying everything together, and so what it takes today for someone to get started as a full stack developer is a lot. There are new paradigms that are thrown at you, and so again, I work a lot with full stack developers, with enterprises and startups. And so when they look at thinking, hey, we want to anonymize our users, for instance, and we'll look at a setup of what that looks like today, they're thrown a lot, actually. So if you look at Circum and Snark.js or setting up or utilizing proofing systems such as Halo 2, there's a lot that they're not familiar with and they need to be familiar with before they can even get started. And so a little bit like how ZK is used today, let's say on the front line, on the front lines. So out there in let's say, quote unquote, the real world, it simply put comes down to privacy or off-chain computation. And so whenever I explain to developers saying, hey, how do you use ZK? Hey, I want to prove I'm Raza without showing you any information about my passport or any of my identities. Or I want to do any off-chain computation that I can verify on-chain, whether that's any fund transfer that happened, or think about games. On-chain games are very costly. They have to spend a lot of gas fees. Now, how can you do any off-chain computation? Let's say we're playing a game. I fight against someone. There are a bunch of steps taken into that game. Each step, how do I make sure we verify? Make sure that we can prove that each step has been executed according to let's say, the way the game says it has been executed, and then prove the end state. And so, real quick, what's the role of scroll? What part of ZK is used on scroll? And I'll tell why it is important. It might go left and right, but it'll make sense in a bit. So when you look at chains, very, very simply put, in ZK, this is an extreme simplification of how zero knowledge on an application level is used. Can you see my mouse, by the way? Well, I hope you can see me. Yeah. What role a chain plays for an application in zero knowledge, which is you have a smart contract where that is utilized to verify, let's say, the validity of the zero knowledge proof, whether it's accurate or not, and a circuit where you define the constraints, i.e., the rules of the rules of that the zero knowledge, the input needs to comply, the witness or the data needs to comply in order to generate the zero knowledge proof. And so the application talks these two things. So a user comes in and provides their data over here. Let's say I'm older than 18, and if that's correct, this lives on the server. A proof is generated, and a user can submit that proof here, and we'll have a full picture in a bit. The smart contract would be able to say, yes, this proof is accurate or not. And then let's say if I'm 18, I'm able to enter the website or the application without actually revealing my data. So that happens on chain. Now, another thing is that not all chains are created equal. At Scroll, we pride ourselves that we're the most ZK, or one of the most ZK compatible for application developers chain. And what does that mean? Right now, if you look at Noir, for instance, Noir is a DSL, a domain-specific language to generate zero-knowledge proofs. If you go to their docs, you'll find that we are the only ZK rollup they work on. And that has everything to do with the fact that the smart contract, for instance, to verify the zero-knowledge proof, utilizes, in this case, pre-compiles called EC pairing. We, for instance, support the processing of EC pairing in smart contracts, and thus a domain-specific language like Noir can work on Scroll. The proofs, the smart contracts that the Noir library generates, you're able to deploy on Scroll and are able to utilize on Scroll. And so, when it comes to what role does a chain play for a developer, compatibility is very important. So you're ready to use zero-knowledge proofs for privacy or off-chain computation. The generation of the proof is one thing, but then the verification is one thing. And then so you need to understand, could you do that just on any chain? And since everything is still built with Ethereum in mind, so the architecture of Ethereum in mind, i.e., what can and can I not do on Ethereum, the constraints on Ethereum. So when they look at rollups, which are, I would say, positioned as EVM compatible, a developer will assume that, I can do everything on a layer 2 that's EVM compatible as well. And that's where a developer needs to check the compatibility and see, are all the curves hashing, and in this case, the precompiled support. And so on the left side, you'll see the dependencies of a chain. And here again on Scroll, we pride ourselves, to be quote unquote, ZK compatible, meaning any tools, developer tools, languages work out of the box, because if they work on Ethereum, they work on Scroll. Real quick, someone might point out SHA-256 right now, for instance, is not supported on mainnet. It is now on testnet, but with our next upgrade planned early May, that will be there as well. So we will be able to support the hash mechanisms SHA-256. Another thing that a developer needs to evaluate is the performance, because zero-knowledge, the current state of developer experience in zero-knowledge proofs is that if you abstract it away, the performance suffers pretty dramatically. So when the generation of proof, whether you're able to generate the proof client-side or not, and whether the framework, DSL, or library works in a mobile application, where at the end of the day, everything needs to work for consumers. And this is very important for developers. I want to give you an overview of tools, and then we'll tie it all together at the end at the last slide. And so today, I couldn't find a good overview, and so it's not a one-to-one accurate. But today, when you want to get started with zero knowledge proof, so depending on what you want to do, you would have DSL frameworks here in the top right, DSLs or frameworks, and these are languages that will allow you to generate zero knowledge proofs based on the constraints that you define in the circuit. So that could be for decentralized identity or privacy, but that could also be for off-chain computation. Over here, you see some decentralized identity solutions that are specifically utilizing zero knowledge proof or some other form of proof. So for someone who who knows proofs ID, it's not entirely zero knowledge proof, to be integrated inside an application. Here on the lower left, you'll see Railgun that's used for payment shielding, which has a very, very interesting setup. If you're familiar with Tornado Cash, they have found a way to make sure that if there is a malicious actor, you can also prove that you're not a malicious actor, i.e., if there is money laundering going on, you can prove that you've not been part of the money laundering in this case. And then EZKL, I will not dive too much into ZKML, but that's where ZK has taken off as well. I think generally speaking, when it comes to developer experience, before a developer starts, developer needs to choose: do I want an agnostic framework or purpose-driven? I.e., do I know that I want to use zero knowledge proofs for decentralized identity, for instance, or do I want to build my circuits from the ground up? And so, very simply put, if it's purpose-driven, you most likely will provide the data in a specific format, in a specific context, i.e., an email address, and then what you pass through a tool, an SDK, so a software development kit, or a framework, is something like an email address, and what it spits out is a zero knowledge proof. Whereas in an agnostic framework such as Noir, which is a DSL, you provide rules in form of code, so constraints. You build up your circuits, and what you then get out of that is a zero knowledge proof. So real quick, what a ZK DApp is. What is a ZK DApp today? Really is all defined by a circuit and a smart contract. A circuit, and I'm sure like the crowd will know that is simply put a program file where you have for instance, if you use something like Node.js, it's a rustic language where you define constraints programmatically. You have a bunch of rules there, inputs in form of parameters, and then it spits out a proof. And your first steps in ZK, usually that I define, what I show with developers is these are the three things that you need to know end to end in order to build a POC. So a lot of things that I do at Scroll is I help early stage projects or enterprises integrate zero knowledge proofs into their application. And then we start with the circuit, make sure they understand the verified smart contract, and then nullifiers, which prevent dumbbell spending, i.e., make sure that a zero knowledge proof is not utilized twice. So a typical architecture today in a POC would be a NOR circuit, a solidity verifier, and then a WASM prover. Now, one of the things that's very, very important on the application side in applied ZK is that not necessarily, but a very shortcut way of thinking it is you want everything to run as much as you can client side when it comes to privacy related, and anything that's not privacy related, it's fine on the server. But then, anything on the server affects decentralization. So that's like a very there's a very easy way of reasoning. There's obviously like a lot more to it. And so usually in a stack demo, what I will do is, and I won't do that today because we don't have the time for it. I think I'm already on time. Would be that I walk them through the circuit, the verification contract, how it's built up, and then how it's integrated on client side and application level, and then I walk through it. These are like important things to know. These are like important things to know again when it comes to sorry, these are important things to know when it comes to hashing functions that are utilized often in the circuits. And you know, again, like I mentioned, it's very important to know that Scroll is compatible with all major circuit verifiers. Finally, I will touch upon is that this is usually what a total overview looks like when it comes to an application. This is a simple verification of someone owns an NFT, and some things that you would pass through the circuit would be, signing a message, making sure that Merkle root, let's say, of all the addresses inside an index of where the address is located in the Merkle root, a signature, a public key, and then once the circuit generates a proof, it can verify it on chain, and an NFT contract where all the data is, let's say, provided for the input of the circuit as well. I gotta leave it at here. I had a hard stop at the top of the hour. If there are any quick questions, I can take them on. I'm not sure if Liam is in the room.
Thank you so much. Thank you so much, Raza.
All right. Thanks so much. See you guys next time. Take care. Bye-bye.
Thank you.